What's up, guys? How have you been? I'm really excited to present you this new tutorial video, which we're talking about a new topic for Autodesk Structural Bridge Design. Today we'll be focused for a complex structural design of from modeling and to add some special load, and so how we can easily design and calculate, analyze this complex composite box girder bridge, as you know here. So it's not the first time I'm talking about these topics. I have many topics talking regarding the bridge interoperability, the bridge workflow between the Autodesk product, especially Autodesk Structural Bridge Design. We can find some insightful content for bridge information modeling into my YouTube channel, where I am talking about many topics about. You can find all this video already done, and today we're talking about this special video. Why I'm so very excited to present this video. Yeah, because I have a good news to talk to you. So guys, today we have more than 10,000 subscribers. Today we have more than happy. It's the reason why I'm trying to make some new tips, using some Autodesk product. So without lose time, we can just begin our modelizations. I save and open a new project here, create, no, excuse me, yeah, I can working with UK annex, I can work in Girder code with French annex. So from my side, I prefer to working with the UK annex. Yeah, of course, first of all, before you begin to modeling in Autodesk Structural Bridge Design, you must firstly parameterize all materials which will be used in your modeling process during all the steps. So first of all, working with concrete slab, so we need to define all proper details. So for reinforcement steel horizontally here for our slab, and the pre-stressed steel horizontally here, so we're working with, and incline it. Why not? So we can make some modifications about the properties if you want. It will be for default, and the steel structure still. And for define the stress and strain, it's very important to define that. You can see it's very simple. So after the second step, is to going to the menu of structure definitions. So you can choose. You have line beams and the refined model. For our refined model, the first thing to do is to add the design line. So no, excuse me, that is the second step. I'm really sorry. I must create maybe a design section or a beam section. So for our case, we will working with a new steel composite girder bridge sections, and we define the first section. We're working with the concrete slab. We define the parametric shape, 2000 millimeters, 5000 millimeters. The depth stay 200, and after the second shape will be with hybrid girds, open box, and we'll make some modifications about the parametric shape, 1 millimeter, and this 1 millimeter. After the bottom flange 200, the web thickness and the bottom flange thickness 300. Yeah, easily we finish our modelizations. After, we can add some concrete story. Excuse me, we'll add some a reinforcement. Here we're working with diameter. How many diameter? Diameter bars 20 millimeters of diameter. We can just change the cover. We can put 300 millimeters. So we have this shape, and we click OK. Yeah, exactly. After we need to change the inertia, the section to make it variable sections. So to make the variable section, we need to define, as we're calling the soffit profile. The soffit profile will allow us to modify our diameter and parametric section to make it very variable. To put inertia, we change his inertia, so we can put here just 10. We divide by 2, and we go to the offset datum 80, 50, 100 millimeter. So we need to change the profile next point. We're working with parabola if we want. We're working with arc. That's very easy. As you can see here, we've been changed our inertia. You see, it's very easy and simple. We have our rebars here. You can modify this. That is we're working with this for alongside of our process of modeling. And after, the next step is to going to structure definition, and going here add as line the design line. Our design line, you select for this defined line segment. I'm working with the transition curve, and I'll select the start point, start angle, and the angle, start point, start angle, and length clotoid. Here I have the easting and mapping 0, because we want to begin at the 0 of the coordinate, the UCS. So our state angle will be 0, our end angle we can put 13, our radius will be 60. So we have this shape. Okay, and after the second we will add is just another arc. We not change here. The second here we can add another arc for the length, and we put here because we have 60, we can put the length here. We can make 20, and we have this. This is our total design line. We have some radius and angle. We have the curve bridge, and so we can add a to-do submodel. The to-do submodel will allow us to create the construction line. Our construction will be parallel of our design line. The first will have maybe we can work in 3 or 4, so we can have 3. Why not 3 design line? Our first design line will work to be around 5 meter, and second line it will be -5 meter, and our third line will be -10, and our fourth line will have, because we have a 4 box, 10. So this is our design line construction. And after we're going to the refine model, we add a span end line. So we need to make some limits of our curve box bridge, no intersection and point. Click here, and here you select this point to this point. Why I do this? Excuse me. Intersection, no intersection. Good. Okay, we have this. It's very important for us to have this because it makes some limitation. Now there is some error here. It's not the last, it's not good. I need to end point. It's not working well, so I can change to put nearest mesh and parameter here. Make some parameter. This parameter will allow you to make it well your meshing. We're working with the finite element, and we're working with play orthogonal design line. The traverse we put F44, 24, excuse me, 24, and the longitudinal we can just add 100, and we can go here, select the first line, second line, third line, and fourth line. We have this. As you can see, it's good as our mesh. It gives us the right design we need. After to do this, meshing, so after to do this meshing, select OK, and you go back at this point. Excuse me. Then we can begin. You go to the design line, you select the open box, our open box. We can just count, and we have 1, 2, 3. I select my first open box. Yeah, I click here, add additional open box, 1, 2, 3, click here, third open box, 1, 2, 3, click here, no, sorry, add open, 1, 2, 3, select here, the other additional, 1, 2, 3, I select this open box. So I finish almost my modeling. As you can see here, it's very a heavy model. Yeah, you can see it's very good to. I've told that I've put 120, but I mean it's just important to put 13660. It's very important to have a good point view of the model design. You can see here it's very good. There is no some error message. So the next step is to go to the structure properties, and from structure properties there is some things to do. You can go in 3D, and in 3D you have some modifications to do. Firstly is to delete all beams. As you can see here, we have all top flange beams, so we can select a true model and go at this plate and select all, and select beam model, and go here, I select all beams model, I click OK, and after to click OK, I can go back to the structure definitions and members details. So I have all beams. I can put control all, my beam selection here, control all, and I can delete all beams to stay only with the finite elements, shape model, 3D model. As you can see here, we have our finite element 3D models, and you can verify here there is no beam. After to do this, you save. The second step is just to launch some calculations. Before to launch some calculation, you need to add some load. So we just come to finish our load, our modelizations. The last step is to add some supporters. You can add some support nodes, and we can select all join. Puff. Sorry, not this. Okay, I begin. So excuse me. Puff. This side and this side, this side, this side, this side, and this side, and I rotate my model to have this side and this side, this side and this side, this side and this side, this side and this side. After to add these fixed supported, the next step is to add some loads. I'll add just two kinds of loads, two categories of loads. The first is I'm not authorized to, especially with the software, to add some road traffic load, because the first in my first modelization I should make I could make some carriageway. I could define some. I should define some carriageway, but I didn't do this. I just put some a finite element load and not lumped mass. No, it's not for dynamic structure bridge. Maybe I can put for the deck path load for the bridge, but I'll put for the temperature change for the finite element, temperature load and external loads. So I can select and add. Maybe I can put 20 kilonewtons by meters, and assign to my all these members, as you can see here. So I can just select. Sorry, yeah, I can exchange, put minus. Voila, yeah, we have this is our first load, and the second load is to add for our webs, maybe, or the overall of a structure. Maybe it's very important to put for the overall of structure is to add I can add a temperature load. The first temperature load is minus 50 for a creep and shrinkage. So I select all my structure. The second load is 10 degrees for the temperature. I select all, and it's okay. No assign here. That is okay. Click OK. That is okay. So if I want, I can put some compilations. I can add that for the traffic load 1, and I'm clicking here, external load and temperature load. I add OK. After, because I will put some because the computer to make these iterations need to have many space, so I need to increase the memory management. You can see here I need to go use define setting. I can put here a 50 megabytes, because we'll have many combination. If I don't do this, I will have some errors. I can't run calculations. So I'm going to tension grids. I can put a 50 and 50. Okay. So after the database memory parameter may also need to be increased. The software asks us to increase the parameter. They are really good. I'm agree with them. They're really reason it's enough. We need to increase our memory management, because we'll have many iterations. So that we can run. So it will just take a few minutes, and we have exactly some result. Increase the core memory option is not enough because the structure is very big, so you need to put maybe 80 and 80. Okay, click OK and run again. We must wait. Output node. You see, it's not easy. It's not. When you are a structural engineer, you must know and interpret some behavior of software. You not to know. You must have the intention to read every message when the software display on your screen. So how we finish our calculations, so we can have some faster result, structural result design. You see here we have some faster result design for the joint displacement, the displacement. So we can put for our compilations some loads for the displacement, the angle. It give you the rotations. There is no rotation. If displacement from Z, here there is some rotation from the supporter here from the extremity. So we have all value. We have our result, and you can swatch. You can look the deflection shape here. You can see here, this is how a deflection shape. You can add the result. That is not the analytic, the design, the dynamic analysis. Not just so you can see the deflection of our shape. Here some small deformation to the static load. And after, you can go for far. You can file the envelope. There is no envelope. We can see the non-influence surface, but we can check here. There is some result, a finite element result. We can see here some membrane. You can see some bending moment with our compilations. You can see here value maximum moment for the shear, and so for the triad X, Y, and so you can see some result, angle, and so. And you can see the virtual member. Virtual member will allow you to see some first the static results, first structural analysis result for the force, our force member from Z. You can see some result here. You can add here results, and you can see, you can look, you can make some parameter. You can see some results. Wait. Yeah, that's okay. We have some results here for our force alongside the deck, a bridge, a gird, composite, and you can see from Z, from fx, and you can see some mx, the bending moment, my, MW. You can see here we have some interesting result from our virtual member. You can see some maximum and the minimum bending moment, and so after to do this you need to you can see as original or need some more enough space for make calculation in the iteration. You need to make this workflow to send your model to Autodesk Robot Structural Analysis for FAF, for FOF, other analysis like dynamic analysis, influence line, surface, and so. But for a small surface, like for the small design like this, for example, as you can see here, for the tree, we can see here we have the influence line here. yeah, influence surface. You see here there is enough because the structure don't require doesn't require many space for calculation and iteration. The memory it's very small. So that is it is the particularity of Autodesk Structural Bridge Design. So, but I am very happy to show these presentations. If you need to know more, you need more details, and so you can contact me in box, and I'll give you some more insightful information about. Thank you so much, and see you later for the next video. Bye bye.